Hello, today we're going to be completing a question on trace tables on assembly language. And under the first question we have here, it has given us an instruction and we must use the table given to us above in order to complete it. So it says INC IX. So IX is the register given. INC is the OP code. So if we look here, we have INC. And it says to add 1 to the contents of the register of ACC or IX. So in this case, we are given IX. So this here is the IX, and we must add 1. So this is basically relating to knowledge on binary addition, but by using the table given above. So if we were to just add 1, it would just be 0, carry the 1 here, and then 1, and then just the same afterwards as there's no more carries. And then if we go on to the next question, we are given a list of instructions in which we must solve. So first of all, we have LDX 90. So if we go to the OP code of LDX, it says indexed addressing. So you take the address and not the contents of the address, but the number address itself, and add the contents of the index register. And if you see down here, we are given that the index register is 2. So in this case, we would add 2 to 90, and then we would copy the contents of this new address to the ACC. So if we look here, 92 is 55. So into instruction 20, like above, we add 55 to the ACC. And then you can just put a tick mark next to the one you've completed so you don't get confused. And then next is DEC, ACC. So if we go here, we have DCC, DEC, and we subtract 1 from the contents of the register ACC or IX. So in this case, we have ACC. So we subtract 1 from the ACC. Just simple here. Just subtract 1 from 55, so we get 54. And you must write it onto the next instruction, not on the same line. And then you can put a tick mark next to that. And then we have SDO 90. So if we go back up and we search for SDO, which is over here, 90, store contents of ACC at the given address. So whatever is stored in the ACC, we would put it into the memory address of 90. So 54. Okay, and then just take it off. And then we have INCIX. And just like we did here for part A, we do ACC-IX. So add 1 to the IX register, which you would do here. So next instruction is 23. So add 1 to 2 and you have 3. And then just take that one off. And then we have instruction 24, which is LDX 90 again. So if we go here, we have LDX. Then we have 90. And you take the address, not the contents in it. So we take 90 plus the IX register, which is now 3 instead of 2. So now we have the address of 93. And we would copy this content to the ACC. So if we see 93 is 34, so now ACC would be 34. And then just take that one off. And now we have DEC, ACC. We can come back here, subtract 1 from the ACC. So now we have 33. And then just take that one off. Now we have CMP90. Compare contents of ACC with contents of the address, which is 90. So compare ACC to 90. So the ACC is 33 and memory 90 is 54. So in order to compare it's basically seen as whether they equal each other. So if they equal each other, it would be seen as true, and if they don't, it's false. So in this case, it would be false as 33 and 54 do not equal each other. So next to it, you can just write false if you want. And then we can go to the next one. So JPE 29. JP 29, following a compare instruction, jump to the given address if the compare was true. So in this case, it was false, so we can just skip that one. And then next we have JPN 31, which is over here. Following a compare instruction, jump to the given address if it's false. So since it was false, we would jump to this address given, which is 31. So we'd go over here. And you can just cross these one out because we're skipping them. And since we're now on instruction 31, you must be careful on which instruction you write your next answer on. So that's why the space is given. You can write whatever instruction you need to be on. And now you just follow as normal. So ADD 93, we have over here, add the contents of the given address to ACC. So whatever the contents in 93 is, which is 34, we add it to the ACC, which is 33. So 34 plus 33 would give us 67. Sorry, that's the wrong store. Yeah, just careful about that. It has to be with the right instruction. So 67, so that's done. And then next we have STO 93, which is store contents of ACC at the given address. So at 93, we just store this as 67. Make sure to keep writing your instructions next to it so you don't get confused as well. Then just take that out. And next is out, which is here. Output to screen, the character whose ASCII value is stored in ACC. So if we go back to ACC, it is stored as 67, and over here 67 is seen as C. So our output would just be C in speech marks. Then next we go to end, which that just means the program ends. So yeah, this is your answer.